Hello and welcome to the Kubernetes podcast from Google. I'm your host, Glen Fields.
And I am Abdel Sigiwar. In this episode, we spoke to Pierre-Gilles, Mialon, and Glen. Pierre-Gilles and Glen are Google developer experts. We had an opportunity to catch up with them at Google Cloud Next, and we spoke about platform engineering, GitOps, and AI.
But first, let's get to the news. Docker Desktop version 4.43 was released, and it introduces a lot of improvements to the Docker model runner. New features include better model management from the interface in CLI with the ability to inspect the model cards. The new version of the desktop also added expanded compatibility for the OpenAI API like streaming outputs. The built-in MCP catalog also received improvements to its searching capabilities. You can learn more about these and many more features in the blog linked in our show notes.
Docker also announced at We Are Developers in Berlin last week that they are expanding Docker Compose capabilities to support deploying apps to the cloud. The first implementation is done in partnership with Google Cloud. You can now use gcloud to deploy a Docker Compose file into Google Cloud Run, including support for GPUs and building containers without a Docker file.
KubeCon Cloud Native Con is returning to Japan in 2026. The event will take place July 29th and 30th in the port city of Yokohama. The first edition of KubeCon in Japan took place this year in June and was very successful with 700 speaking session submissions and a completely sold-out event with around 1,500 attendees. I, Glen Fields from the Kubernetes podcast, was there and recorded some behind-the-scenes interviews. Look forward to these coming out soon. And that's the news.
Hello, everyone. Welcome back. This is Abdel from the Kubernetes podcast. We are live from Google Cloud Next 2025, and I have with me Glen and Pierre-Gilles. Hi, folks.
Hello.
Hi. How are you doing?
Doing well. It's the last day. It's starting to get a little tired, fatigue settling in, but no, it's been great.
Yeah, Next was insane. It's 33,000 people in Vegas in the middle of the desert. So
I certainly got my steps in.
Oh yeah, I've been averaging like 25,000 steps every day.
Yeah.
It's insane. All right, so let's start with some introductions. Gilles, who are you? What do you do?
I'm a cloud champion and I help companies in their journey to the cloud, mostly with Kubernetes.
Awesome. And you probably haven't figured it. Pierre-Gilles is French and he has a very cute French accent. And Glen?
Yeah, hi, I'm Glen. I'm based out of Toronto. I work for PwC, which is a Google partner. Personally, I've been a Google developer expert for Google Cloud for 5 years now. I'm also a member of the Kubernetes policy working group and the Kubernetes infrastructure lifecycle working group. So I'm quite involved with a lot of the Kubernetes aspects.
Awesome. And yeah, so you, as you mentioned, you're both Google developer GDs on our GD program. So we'll start with you, Pierre-Gilles, because in the way you describe the work you do, you brought up like a bunch of words that I am quite familiar with. GitOps. Where are we on GitOps these days?
The main issue is the infrastructure is to be sure what is running on. And one way to ensure that is to put your definition in Git and ensure that you have something that reconciles what you exactly described and put it in your clusters. And you have many ways to achieve that. GitOps is a practice that exists for nearly 7 or 8 years. The tools have changed during this period, and now we have a great way to ensure that what is running is really what we want.
All right. Yeah, and in a way, GitOps just leverages the reconciliation concept in Kubernetes, right?
Yeah, it also ensures you that what you want is what you get. Because GitOps ensure you all the Git principles, so you know that if something changed, someone has committed something.
Yeah.
And so you have traceability, you have reversibility because you can roll back your. Yeah. It's a Git revert.
Yeah.
And you have it's easy to read. You can see the change by reading your Git log. You have all the story of the evolution of your infrastructure.
All right, cool. And so in this space of using GitOps practices to deploy apps, deploy infrastructure, deploy stuff, and even like policy as code, which is the stuff that you, Glen, work on. There are basically two camps. There is the Terraform, Pulumi kind of bash script camp, which is write code that does stuff. And then there is the KRM camp, the Kubernetes Resource Model camp, which is using Kubernetes as a way to drive infrastructure management. I'm certainly in the second camp because I pretty much like Kubernetes. But so what's your take on that, Pierre-Gilles? Which one do you like first and why?
I'm an early adopter of Terraform and other tools, infrastructure as code, but with time, it seems to me that the KRM is definitely the best model, as you said, because you can avoid the drift.
Yes.
This is one of the great features is that you can avoid the drift. Another thing is that using a Kubernetes resource model, you use YAML. YAML is not the best thing in the world, but it's purely declarative.
Yeah.
So there is no language. This is a description.
Yeah, it's a config.
When the API of the cloud provider change, you don't have to change your definition.
Yes.
What will be changed is the reconciler behind the scene that will be upgraded, but your definition will stay the same. Something you didn't have. One of the most issue with Terraform, I think, is maintenance cost. I use a code that I wrote in a KRM model I wrote them 4 years ago, and I still continue to copy paste and use it.
Yeah.
This is purely declarative. It's still working. I don't think that you can find a piece of Terraform code that worked 4 years ago and that still works today.
And this is because like cloud provider changes their API and then you have to update your code?
Yes, the way your company managed the Terraform code too, because you have style in Terraform.
Yes.
The way the pipeline are really complex. When you use Terraform, you sometimes use orchestration. So you still need to apply this model first and this one secondly and this one after. In a KRM model, you don't have that. You put everything together and let's reconcile. It's a Kubernetes spirit.
Yeah.
So even if it doesn't work, your resource cannot be ready for 1 hour because it took many times to reconcile the dependency of this resource, but it will work at the end. And you have only one operation, but with Terraform, you will have issued 7 operations. And we know that the incident came from operations. So,
yeah.
Yes, you follow the procedure, step 1, step 2, step 3, or oopsie daisy, there is a step 2.5 that
broke.
That was missing and that was not mentioned in the procedure because the infrastructure has evolved between the days the documentation was written. So,
yeah, or it could be as simple as you run a Terraform script and then one thing does not deploy because you don't have the right permissions.
Yes.
And now you fall into this situation where you either have to rerun it one more time, but sometimes it doesn't work because some resources can only have a unique name, and then you have to go manually clean everything and then run it again. But I like the way you described like the Kubernetes resource model, which is, it's an eventually consistent system. So eventually everything will reconcile.
Exactly.
And everything will get created or updated or whatever, right?
What you ensure with the KM model is if it works in an environment, if your infrastructure converge, you are sure that it will converge in the other environment. So during qualification, you really have a fully qualification of your code.
Yeah.
Of your description. It's not really code.
Yeah, it's declarative. And when you describe this thing of the reconciling dependencies, like things, if you have to create this thing first and then create this other thing second and then create this other thing third. Yes, KRM helps in the sense that object A will not be created if it depends on object B, and object B has to be created first. So it will wait until it will not wait. It will keep trying, basically.
It depends on the implementation of your KRM model because sometimes your KRM model is aware of the necessity of creating dependency.
Yeah.
It doesn't work for everyone, but in the end, it's just a matter of time.
Yeah. And so in that space, that's what KRO partially was trying to solve, right? Like the Kubernetes Resource Orchestrator, which we did an episode about on the podcast with Nick and Jesse. But KRO has that capability. It basically has a DAG, a built-in graph, so it can resolve the dependencies. What's your take on KRO?
I think this is amazing because once again, we were talking about Terraform. Most of us, the executive, are thinking that if they use Terraform, if their teams use Terraform, they will be able to deploy everything in every cloud, which is not true.
Yeah, it's not cloud agnostic.
Yeah, you should rewrite your infrastructure with the appropriate provider for AWS, Azure, or GCP. The promises behind Crow is that you can abstract concepts. You can abstract concepts at another level and hide the resources, the true resources of the cloud provider. And so you can create real declaration. This way, you have the world is offered to you because you have the first abstraction of the KI model that ensures that it will reconcile. And secondly, you have the abstraction of you abstract the provider and through a YAML. And the second one is the collection of YAML you need is abstracted to. There is a security issue behind this because you can offer the opportunity to your developers to deploy my database type,
Yes.
a CRD, but ensure that they won't be able to create Cloud SQL instances.
Yeah.
And this way you can ensure that the way they deploy Cloud SQL are defined by your platform team and ensure the best practices and the best security practice around this.
Yeah.
So it achieves the promises that Terraform didn't have.
Yeah, and that's actually one of the features I like about Kero, which is simplifying or hiding certain security things that I don't want to make developers to create a database that has a public IP, for example.
Yeah.
You can just hide that way. So that's actually a good segue to you, Glen. You worked on this paper for Kubernetes called Shift Down Security, for Kubernetes Security Shift Down, right?
Yes.
And we've been hearing this thing of shift down quite a lot. That's what Terraform also is trying to achieve in a way. So what's that paper about?
It's about policy as code. I like how we talked about infrastructure as code first, because if you think back about what infrastructure as code kind of solved is like people used to kind of build their servers manually. And it's very error prone. And so something like infrastructure as code makes things more declarative. You can do things more repeatable. And it's also in of itself a live documentation.
Yeah.
Right. And after your resource gets deployed, it doesn't stop there. It's, I have my server, I have certain things configured, certain things enabled, network, whatnot. But what happens inside, right? A lot of the configurations of the applications or the IAM or other settings in there, people still do manually.
Yeah.
Policy as code takes that principle that infrastructure as code solved for infrastructure and is applying it to securing and hardening the resources that you've already deployed.
All right. Can you just, for the sake of clarity, can you give us like some concrete example of what would you do with security as code? Maybe because I've been hearing about tools like Kyverno, which is one popular one, but yeah, just an example.
Okay, so Kyverno is a tool that I quite like. So you can set policies in your Kubernetes clusters that say you have to have a certain tag. It needs to have a service account, or it cannot be in the default namespace, and other things like that. Or when you deploy a container, it can't have a latest tag. Little things like that you can't, after you've deployed Kubernetes, you can't always be there watching what everybody does.
Yeah.
Make sure that everybody does the right thing.
Yeah.
So something like policy as code puts in these admissions controllers that will say, hey, you're trying to deploy something with the latest tag. You should have an explicit version, right?
Yeah.
Or you don't have the appropriate tags, or you're trying to deploy in the default namespace. These are some things that you need to fix.
All right. Yeah, and that's actually, these are stuff that you could also effectively orchestrate through the Kubernetes resource orchestrator, right? Or abstract away the high-level implementation details. So in this day and age, there is this thing called platform engineering, and everybody seems to be a big fan about it. And to me, it's funny because it seems like what DevOps have been trying to solve for a very long time is the separation of concerns between development and operations, and so to blend these two things together. And now the way platform engineering feels is going back to that age where we have the platform at the bottom and then the applications at the top, and just give me a platform where I run my apps and don't talk to me. So my follow-up question to that is, or my question to this is, where do you see security challenges within this platform space?
The main principle about shift down is you want your platform to be secure by design.
Yeah.
Which is a little bit different from the shift left that was very popular a few years back. But I think shift left is a little bit lazy in a way. It's good that developers take security into account earlier, but at the same time, that's not their bread and butter. That's not what they specialize in.
Yeah.
And you're trying to put a lot of the onus on securing your app and the platform that it runs on onto developers. And I think that's not a full secure solution. Security is everybody's responsibility.
Yeah.
It's not just developers, but also the platform teams, the security teams. They need to do their part to make sure everything's secure. Now, some of the challenges that I think platform teams will face is that there's usually that disconnect in communications between them and the application team.
Yeah.
So there are things that they might not talk about, or they don't know what to ask, and there might be things that get left out.
Yeah.
So that's where things like policy as code and things help. So that's where they come in to really help create a good baseline.
Yeah.
For what
guardrail.
should be a guardrail for what should and shouldn't be.
Yeah.
Right.
Yeah.
Now, like I said, it's everybody's job, everybody's responsibility.
Yeah.
You need everybody to do their part and work together to make something safe.
Yeah. And so I'll go back to you, Pierre-Gilles. Do you have to, since you work on automation and Flux CD and KRM, KCC and all that stuff, is security something that you like touch and be concerned with?
Yeah, it's at every step.
Okay.
I share what you said. One of the issues with Kubernetes is when it was created to ensure that you can run everything.
Yeah.
And running everything is not a good idea in a world where people create porn application.
Yes.
We don't need to see postfix running in a Kubernetes server.
Yeah.
But when Kubernetes was created, it was created to allow that. So the default policy on a Kubernetes server are far too permissive.
Yeah.
And for this reason, I ensure that, for example, I use a per admission
Controller.
for every namespace, of my customer. And I had policies, as you said, because I don't want that developers is about to create a service type load balancer.
Yeah.
For example.
Of course, yeah. And so I do have a follow-up question. It's actually not a follow-up question because preparing for this episode, I was looking at your blog on Medium and you wrote something about Nomad. And it's funny because we are all kind of way too deep. I'm talking about myself. I'm way too deep into the Kubernetes space that I just assume that's like Kubernetes is the only orchestrators that exist. And the even funnier thing is yesterday I was talking to a software engineer from this company called Fermion. They do WASM and they use Nomad for their cloud serverless functions, WASM service functions. So what's up with Nomad? Is it like big?
No, it's not. It's got a really small market share. I think there's some niche industries that do use it.
Yeah.
But I think it was out around the same time as Kubernetes. It's from HashiCorp.
Yeah.
It's their workload orchestrator because they do more than just containers. You can orchestrate Java apps.
It does more than it does only the containers.
So containers is a huge part, but that's one of the things that it can do. Early in my career, I did quite a bit of work with Nomad, and I find that it is, and this was probably like 6-7 years ago. Kubernetes was still fairly early. We still don't have a lot of the tools that we have today.
Yeah.
And even like from a managed service standpoint, it wasn't available.
Yeah.
Nomad was a good, easier alternative, especially for like smaller companies back then who didn't have the knowledge to handle the people to handle the complexity of Kubernetes. I would say it would be somewhere that falls in between, say, like Docker Swarm and Kubernetes. It falls somewhere in between in terms of complexity.
Yeah. And so one more tool I want to talk about, this is going to be my last question. And do you work with Flux CD?
No, I like Flux CD. I've tried it a bit, but I've been using Argo mostly.
Yeah, and so it seems like we're in this space now where there is, again, two camps. There is the Argo CD camp and the Flux CD camp. Can you, Pierre-Gilles, briefly, because you work with Flux CD, what do you like about it? What's up with Flux CD?
It's in the spirit of Kubernetes.
Okay.
It respects everything. The role-based access control of Kubernetes, it doesn't rewrote something above it. So, yes, it's really Kubernetes spirit.
I will tend to agree, and I really like the command line aspect of Flux CD.
Mm-hmm.
It's a lot more command line. Argo CD is a little bit more visual, but at the same time, like, if I was working on a personal project, I might use Flux CD.
Right.
I work as a consultant, and a lot of clients, they like Argo, so that's very understandable. So I see a lot more Argo. I'm coming from a consultant background, right?
Yeah.
So it's very different.
There is one more thing about Flux. I think that for developers, they shouldn't use CLI. The idea behind Flux CD is that you rely on notification. And in your real GitOps, what you want to do is the developer should work as fast as he can. So he put his code, the code is compiled by the CI, it's deployed by Flux, and if it succeeds, you have a notification that tell you the development is okay. Then you can go to the next step. And the idea is that you don't want to lose your time opening a web UI.
Yeah.
Because normally, if everything is good, continue to work on your stop the interruption and you don't have to check what's happened, because if the way you deploy your application is straight, then you don't have to focus on that.
Yeah.
Concentrate on your work.
Yeah. Tell me only when things broke, but
Yeah.
when things are working, I don't want to know.
Exactly.
Yeah. Awesome.
Alert me when it fails.
Yes. All right. Well, awesome. Thank you very much, guys, for being on the show. This was really good conversation, and we'll make sure to link your socials on the episode when it's out. Thank you.
Yeah, absolutely.
Thank you.
Thanks for having me. Thanks for having us.
That brings us to the end of another episode. If you enjoyed the show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on social media at KubernetesPod or reach us by email at kubernetespodcast@google.com. You can also check out the website at kubernetespodcast.com, where you'll find transcripts, show notes, and links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.